Welcome to spmathsolutions, real numbers, 10th class maths, exercise 1.4. First problem, prove that the following are irrational. First bit, 1 by root 2. Solution, given number is 1 by root 2. To prove 1 by root 2 is irrational, let us assume 1 by root 2 is rational. Why we are choosing the contrary way? The given number is rational because we know that an irrational number can't be represented in the form of p by q. That's why we are choosing the contrary way. It is rational. Now I have to prove our assumption is wrong. Irrational number p by q form లో రిప్రజెంట్ చేయలేము అనే పాయింట్ని బేస్ చేసుకొని ఈ ప్రాబ్లమ్ సాల్వ్ చేస్తున్నాం. We know that irrational number is in the form of p by q and q not equal to 0. P, q are integers. That's why we have to write 1 by root 2 is equal to p by q, p comma q not equal to 0. Cross multiplication 1 into q is equal to root 2 into p, root 2p. That is equal to root 2p is equal to q. Root 2 is equal to q by p. P, q are integers which is a fraction form. Root 2 is in fraction form which is a rational. That's why root 2 is also a rational number. It is a contradiction. Why it is contradiction? In general we have root d is irrational. D is positive integer and d is not a square of an integer. Here root 2 is not a square of an integer. Root 2 is irrational. Root 2 is rational is contradiction, which is raises due to our assumption. Therefore, our assumption 1 by root 2 is rational, which is wrong. Therefore, hence given 1 by root 2 is irrational. Hence proved. Second bit, root 3 plus root 5. To prove root 3 plus root 5 is irrational, we have to suppose that root 3 plus root 5 is rational. We know that a rational number is in the form p by q. That's why root 3 plus root 5 is equal to p by q. P comma q not equal to 0. P, q are integers. Now squaring on both sides, root 3 plus root 5 whole square is equal to p by q whole square, which is in the form of a plus b whole square is equal to a square plus b square plus 2ab. That implies root 3 whole square plus root 5 whole square plus 2 into root 3 into root 5 is equal to p square divided by q square. Square and root are cancelled. 3 plus 5 is 8 plus 2 root 15 is equal to p square divided by q square. Therefore 2 root 15 is equal to p square divided by q square minus 8. 2 root 15 is equal to denominator is q square, numerator is p square minus 8 into q square, 8q square. Therefore root 15 is equal to p square minus 8q square divided by 2q square. 2 మల్టిపుల్గా ఉంది, ఈక్వల్ టు గిట్ సైడ్ వస్తే డినామినేటర్ అవుతుంది, విచ్ ఈజ్ ఇన్ ఎ ఫ్రాక్షన్. pq are integers and p square minus 8q square divided by 2q square is a rational number. That is equal to root 15 also a rational number, which is a contradiction. Root 15 is rational is contradiction, which raises due to our assumption. Since we have root d is irrational, d is positive integer and d is not a square of an integer. Root 15 is rational, which is contradiction. Therefore our assumption root 3 plus root 5 is rational, which is wrong. Hence root 3 plus root 5 is irrational. Third bit, 6 plus root 2. Solution, to prove 6 plus root 2 is irrational, let us suppose that 6 plus root 2 is rational. We know that rational number is in the form of p by q. That's why 6 plus root 2 is equal to p by q. Root 2 is equal to p by q minus 6. Write 6 as 6 by 1, which is in the form of p by q. See here, fraction minus fraction. These two are rational numbers. The difference between two rational numbers is also a rational number. That's why root 2 is rational, which is a contradiction. Root 2 is rational is a contradiction. Contradiction raises due to our assumption 6 plus root 2 is rational. That's why our assumption is wrong. Therefore 6 plus root 2 is irrational. హెన్స్ ప్రూవ్డ్. మీకు ఈ వీడియో నచ్చినట్లయితే కామెంట్ చేయండి, సబ్స్క్రైబ్ చేయండి.